Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how we learn new words and why some things stick in our brains better than others, especially when we're picking up new patterns from others? Well, this new study explores exactly that. So imagine these researchers are looking at how people learn and adapt when they hear new words, especially word parts like suffixes or prefixes. Think about how the past tense works in English. We add eds to most verbs like walk to walked. But then there are those tricky irregulars like go to went. How do we learn these? And how do we adjust when we encounter new patterns? This study dives into that using a cool computer model and actually a real online experiment. Basically, they wanted to see if a learning model, kind of like a simplified brain for learning language, could mimic how people learn when they are, for lack of a better word, influenced by somebody else. They had people play a word matching game with a computer-controlled partner, and saw if they adapted their language use. The big idea was to see if they could make a computer model adjust its learning rules. Not by just creating brand new rules every time, but by tweaking the rules it already had based on what it learned from interacting with this fake partner. This is different from a lot of other studies that usually just train a model on a big pile of existing words and see how well it can guess new words. Let's talk about how scientists try to understand how we learn language. Historically, they looked at how similar words kind of hang out together in our minds. Think about the English past tense. There is the regular way, adding "eg", and then there are the irregular ones. Early ideas used computer models that looked at how words are similar to each other. Some models are inspired by how our brains work, like those that use something called Hebbian learning, which is basically neurons that wire together. Others are more like our everyday categorization skills. But here is where this specific study gets interesting. They're using a model called the minimal generalization learner. This isn't just about word similarity, it is designed to look for specific patterns, like a little transformation rule. Imagine a rule that says, if a word ends in K and the sound before it is voiceless, add a T sound for the past tense. This rule is very specific. It is like a little linguistic detective looking for precise matches. The learner gets a bunch of examples of words and their past tense forms, and it finds these specific rules. Each rule has a score that tells us how reliable it is. The more often a rule works and the more examples it fits, the higher its score. For instance, the study talks about a non-word like splink. They trained the minimal generalization learner on a huge list of real English verbs. The model found rules like one that says add a t at the end for the past tense, which applies to tons of verbs like look and want. It also found a more specific rule that changes the vowel in words ending in ink to ank, like drink becoming drank. This second rule is more specialized and applies to fewer words. Using these rules and their scores, the model can predict if splink will become splinked or splank. So these rules are like generalizations. They capture patterns. The study mentions how the minimal generalization learner was really influential because it combined ideas from linguistic theory, like how rules work in grammar, with the idea that we group similar words together in our minds. It helped move away from the idea that we have totally separate systems for regular verb endings and irregular ones. Now, moving beyond just how things are listed in the dictionary, real conversations are super important. When you are talking to someone, what you and they say influences what comes next. This is called linguistic convergence. It is a big reason why languages change over time, and this even happens with made-up words researchers use in experiments. These non-words can start to behave like real words, getting influenced by what came before and influencing what comes after. This brings us to the actual experiment. Researchers had people play a word-matching game. They had fake co-players who were programmed to act in different ways. Some co-players were typical, meaning they followed the normal English rules. Others were reversed, meaning they did the opposite, making splinked into splinked instead of splanked. And then there were random co-players. Participants had to try and match their answers with their co-player. Crucially, they did this in stages, a test before interacting, during the interaction, and a test after. They then tried to use two types of computer models to explain what the people did. One was this analogical model, which is more about word similarity, and the other was the rule-based minimal generalization learner. Before the interaction, the rule-based learner was better at predicting how people would form past tenses. But here is the twist. After interacting with the co-player, the analogical model got better at predicting what people would do, but the rule-based model, in the way they originally set it up, didn't. This suggested that maybe the old way of running the rule-based model wasn't good at capturing how quickly people adapt. So, the big question for this current paper was, can we tweak the minimal generalization learner, this rule-based model, so it can capture this rapid adaptation? This quick change in behavior we see in people. They thought maybe the problem wasn't that rules are bad, but how they were being used. The old way was to completely rebuild the rules from scratch using the new information. Imagine if after hearing "go went" a few times, the model throws away all its old rules and tries to create a whole new set, just based on this new example, which is probably not how we learn. Instead, they proposed a new idea, rule updating. Instead of rebuilding all the rules, what if the model kept its existing rules, which are based on tons of real words, but just adjusted the confidence or the strength of those rules based on the new interactions? So, if the co-player consistently partnered sing with sang, the rule that turns I to A in ing, words would get a confidence boost if the co-player made a mistake, that rule's confidence might drop a bit. They decided to test this rule updating idea, specifically focusing on the reversed co-player condition, because that is where people were really pushed to change their behavior. They compared 3 models, one that only used the original big list of words, the corpus, only learner, the old rule building model that rebuilt rules for each person based on their interactions, and their new rule updating model. And what did they find? The results were pretty exciting. The original rule-building model didn't do much better than the basic model that just used the big list of words. It wasn't reliably explaining the changes in participant behavior. But their new rule-updating model, it showed a clear effect. They are 99.9% certain that this model is predictive of what people do after interacting. This means that by simply adjusting the strength of existing rules, rather than rebuilding them, the model could capture the rapid adaptation people showed. They also looked at another way to measure accuracy using something called ROC curves. This shows how well a model can tell the difference between regular and irregular verb endings. Here, the analogical model, the one based on word similarity, was actually the most accurate. But the rule-updating learner wasn't far behind. It was pretty good, even though it sometimes predicted slightly too many regular endings. This might be because their updated model only adjusted the regular rules, and in English, the regular pattern is super common, so these rules have a huge lifespan. So, what does this all mean? The study suggests that for rapid learning and adaptation, like what happens in a conversation where you are picking up on subtle patterns, an updating approach is much better than completely rebuilding your understanding from scratch. The minimal generalization learner, when it is allowed to update its existing rules based on new input, can actually do a great job of capturing how people adapt their language use on the fly. This challenges the idea that models need to be strictly rule-based or analogical. Perhaps they can be a blend. The researchers also think that this way of updating rules might be very similar to how our brains actually learn, possibly like Bayesian updating, which is a mathematical way of updating beliefs as you get new information. They emphasize that this rule updating approach is a new way to use the minimal generalization learner, moving beyond just simple WOG tests, which are those experiments where people conjugate made-up words. Now, like any study, this one has its limits. For example, the experiment had people encountering a lot of new irregular words in a short time, which isn't exactly how most of us learn the English past tense, which has very few new irregulars. Also, the specific set of words used for training could influence the results. But the core finding that updating existing rules is powerful for rapid learning is really strong. This research is super cool because it shows that learning might not be about throwing away old knowledge and starting over, but about finely tuning what you already know. It means that the way we adapt to new linguistic patterns is more fluid and dynamic than we might think. What this study really highlights is that linguistic adaptation, whether it is the past tense of verbs or subtle changes in pronunciation, is an active, ongoing process of adjusting existing knowledge rather than constantly reinventing the wheel. This has implications for how we think about language acquisition, language change, and even how artificial intelligence might learn language more effectively. What do you think about this? Does this make sense with how you learn new things or pick up on new language patterns? Let us know in the comments below. If you found this interesting, give this video a thumbs up, subscribe to RUBIN'S Mind Lab for more science explained, and hit that notification bell so you don't miss our next dive into the fascinating world of the mind. Thanks for watching, and we'll see you next time.